news recently. So thinking about how communities assemble at different snapshots in time is really very interesting to me. And we might imagine that different processes are relevant at different time points in that kind of eco-evolutionary process, and there are times when the system could be in a steady state, times when it's not in a steady state, and kind of how does that whole dynamic lead to this incredible diversity that we see. These are a collection of charismatic mesofauna from Hawaii. So the way that I've approached this is combining a lot of field work with these kinds of organisms with theory. This is an example of some recent work on linking neutral and non-neutral macroevolution, microevolution, and macroecology in a temporally dynamic model. So trying to use that to understand these phases of stationarity, non-stationarity, the role of immigration versus speciation, competition versus environmental filtering. But I've also worked in using more ideas from statistical mechanics to kind of characterize this stationarity, non-stationarity. And this could have some exciting relevance for remotely sensed data because we're using very coarse-grained state variables. We're using total number of individuals, total amount of metabolic energy flux through a system, total number of species, to derive really microscopic or fine-grained predictions about the distribution of abundances, distributions of species across space. And then another exciting approach that's kind of our take on remotely sensed, it's a very different kind of remotely sensed biodiversity, but on the same scale that we have, I don't know what order of magnitude, let's put it at gigabytes of remotely sensed data. We really do fundamentally lack the same for biodiversity. So if we could very easily take organisms, pump them through some pipeline and get information about species and genetics and traits, that would be great. And this is our attempt to do that, which we can talk about more. But and then interesting predictions, like how do these parameters change through time? When we predict the wrong amount of diversity, is it because different processes are relevant that we didn't expect? So to do that, we have to combine all these data, and I thought I was going to be in the bioinformatics section. So this is my attempt. We put it all in a silo, and that's a really challenging thing. Anyway, I'll wait here another second so I can get a hug, and then I'll be done. Thanks very much.